This lecture is on germ theory. Germ theory is the understanding that microscopic organisms can cause disease. Things like bacteria, viruses like SARS-CoV-2 that causes COVID, as well as parasites. I'm going to be talking about some of the history of microbiology here, some of the major developments over the course of microbiology. Most of the information I have is on what happened in the Mediterranean region and in the rest of Europe. This does not mean that other cultures and other societies weren't figuring things out at the same time, but it is the history that I have the most easy access to and that I understand the best. So we're going to start a couple of thousand years ago in ancient Greece, ancient Rome, and ancient Israel. All of these cultures understood that diseases could be contagious or spread from person to person. And they thought that the transmission was in some sort of seeds or miniature creatures that were too small to be seen and were small enough to float on the air, which is really close to what we now understand to be true. The medieval Islamic world in the Middle East noticed that people could pass tuberculosis from one person to another with their breath. They developed an early form of germ theory based on unseen particles or miniature bodies. Again, really close to what we understand to be true now. This started, well, the earliest recorded version we have was in 1025, and it was widespread by the 1500s in the Middle East. A Jesuit priest and scholar named Athanasius Kircher was the first person who observed microorganisms, and this was in 1646. Now, modern microbiologists are not sure that he actually saw microorganisms. He was looking at blood samples and may have just seen blood cells. But regardless, he called these animalcules, which kind of means small animals. And he believed that these tiny creatures caused disease and decay. At this time, plague was a recurring problem throughout most of the world. And plague has a 50 to 70% fatality rate. So we're going through a pandemic right now, and in the US, we've actually lost about 0.5% of the population. Imagine a disease that would wipe out half of the population at a time. So this scholar, Kircher, proposed isolating people with the plague so they couldn't spread it to other people, and burning the clothes of plague victims. Very often, when somebody died, their clothes would be passed on to other members of the family. And so he was saying, no, we should burn their clothes. This wasn't really taken up very well because a lot of Europe at this time believed that diseases were due to miasma. Miasma just means bad air. You can understand why they would believe this. Lots of contagious diseases are airborne, and you'll see them occur in a common area. So you'll have an outbreak in a small area. And the idea that they had was that the diseases would be caused in this local area due to bad vapors in the area. And bad vapors was just a general idea of smells, right? There's something wrong with the air here. And this idea persisted into the mid-1800s in Europe. John Snow was an early adopter of germ theory in Europe, and he identified the source of a cholera outbreak. Cholera is a waterborne disease that has a 25 to 50% mortality rate if it's untreated. We can treat cholera nowadays, we can treat plague nowadays, and even if when these diseases pop up again, they have lower mortality rates than they used to. So he identified a water pump in London as the source of a cholera outbreak. This is how people were getting their water at the time. And he convinced the local government to remove the pump handle. The outbreak ended. The government replaced the pump handle because, people have to get their water. We don't want them having to walk longer distances. And fortunately, the disease did not come roaring back. Probably because it did stop the immediate transmission, and cholera does not survive long periods in the water supply without if they can't infect somebody. We think that the removal of the pump handle allowed the infected individuals to recover, and they were no longer able to transmit bacteria through the water. John Snow recommended that water should be filtered and boiled before use to prevent the spread of waterborne diseases. And certainly, this still works. There are various ways to filter and purify water to prevent these waterborne diseases. In the 1860s, Louis Pasteur discovered that bacteria could cause disease. So, bacteria had been seen under primitive microscopes, and they were associated with disease. But at the time, a lot of people thought diseases caused bacteria rather than the other way around. But he developed a sterile technique to grow pure cultures of bacteria, which he could then inject into healthy animals and cause the disease. So this was a way to demonstrate that the bacteria were causing the disease. Our next major development was from Robert Koch. Koch developed the basic criteria that said, this is how we can determine that a particular disease is caused by a particular organism. This process, Koch's postulates, has 4 basic steps. The microorganism must be found in all organisms suffering from the disease and not be found in healthy individuals. Okay, so the bacteria is in animals with the disease and it's not in healthy animals. Then you isolate the microorganism and grow it up in a pure culture. So you grow it in such a way that that's the only thing in a particular culture, in a liquid culture or on agarose plates, as shown in this diagram. Then you take that bacteria and inject it into a healthy organism, which then gets sick with the with the same disease. And lastly, you have to be able to get that microorganism out of that diseased organism, the same microorganism that you originally injected into them. Okay, so not great for the animals you're experimenting on, but it's pretty clear cut. You've got a diseased organism, you isolate a bacteria, you put that bacteria in a healthy organism who then gets sick, and you can still find the bacteria in it. Well, there are, of course, problems with Koch's postulates. It's just a starting point nowadays, because microorganisms do not always cause disease. SARS-CoV-2, some people get asymptomatic cases. They can catch the virus, but not get sick from it. Unfortunately, they can still pass it on to more vulnerable people. This is because the immune system, which is there to protect us from these sorts of things, often prevent disease. The next problem, you can't grow viruses in pure culture. And some bacteria cannot grow in pure cultures. So you can't get a pure sample of these viruses or bacteria, or at least not very easily. Although modern technology is making it easier to isolate these sorts of things. What if those viruses and bacteria that are causing diseases in humans do not cause disease in animals? That can be tricky. How can you prove that something causes a specific disease if you can't cause that disease in animals? And of course, there's ethical issues here too, right? And certainly, ethically, humans are not deliberately infected with disease. Well, I say that, but there certainly have been cases and times where humans have been experimented on and deliberately infected with diseases. Ethically, it's wrong, but it has happened. Now, in modern times, we start with these ideas of Koch's postulate, but we use different techniques and we don't always have to infect an organism. We can use things like DNA sequencing. This is really good for viruses. We use electron microscopy, which allows us to see viruses. Viruses are incredibly tiny, and you cannot see them with a standard light microscope. The development and understanding of germ theory has led to several very important things. The understanding that hand washing is important in medical settings, especially, and that medical equipment needs to be sterilized. It has led to the development of antibiotics and antivirals. And let's look at this graph. We have on the x-axis years starting in 1770 up to 2019, and life expectancy on the y-axis. So you can see that from the 1700s through towards the late end of the 1800s, life expectancy was pretty steady at about 35 years. Now, life expectancy does not mean that the average person lived to be 35 years old. What it meant was if you took the age at death of everybody born in, say, 1801, looked at how long they lived, and calculated an average, that's what you would get. The problem is, during this time period, childhood mortality was nearly 50%. Half of all people died during childhood, usually during the first 5 or 6 years of life. So if you got past being a teenager, if you made it to being a teenager, you were likely to live 60 or even 70 years. So a lot of the improvement in life expectancy is reduction of childhood mortality. And you can see, here we go, germ theory starts up right around here in the late 1800s. Hygiene becomes important. We start understanding how disease spreads, and look at how fast that life expectancy shot up. Until now, in Europe and the Americas, basically what we call the Western world, life expectancy is in the mid-70s. Now, you will notice that Asia had kind of a lag, but is catching up with the European world, the Western world. Worldwide, there was a lag, but there's some catching up being done. And Africa is unfortunately lagging quite a bit behind and has the lowest life expectancy. And sadly, that is largely due to childhood mortality. So, two last points on this chart. The first of which is life expectancy in North America, specifically the United States, is actually pre-COVID was already kind of declining a little bit. And there's a huge, huge difference in life expectancy and childhood mortality in the United States, depending on the color of your skin. African Americans and Latinx Americans have lower life expectancies and higher childhood mortality than do white Americans. All right. So that, yes, that kind of wraps up the germ theory thing. I went a little bit longer than I like to on these things, so I apologize for being a slightly longer lecture, but hopefully you got some interesting information out of it.